Ever wondered how computers predict future trends based on past data? It's like a crystal ball, but instead of magic, it's driven by a concept called linear regression. This gem of machine learning is the secret sauce that helps machines predict future outcomes based on historical data. It's the reason why your weather app knows it's going to rain tomorrow, or how stock market trends are forecasted. If you've ever been curious about this, you're in the right place. Linear regression, at its core, is a statistical method. Let's take a moment to unpack that. What exactly is linear regression? Well, at its simplest, linear regression is a way for us to understand and predict the relationship between two variables. Think of it as a way to draw a line of best fit through a scatter plot of data points. This line can then be used to predict future values. Now, these two variables we're talking about have special names. We call them the independent variable and the dependent variable. The independent variable is the one we control or manipulate. It's the cause in our cause and effect relationship. The dependent variable, on the other hand, is what we measure or observe. It's the effect that changes based on the independent variable. Still following along? Great. Now let's dive a bit deeper and talk about the equation of a line. In linear regression, we describe this relationship between the independent and dependent variables using the equation y equals mx plus c. Here, y is our dependent variable, the one we're trying to predict. X is the independent variable, the one we're using to make that prediction. M represents the slope of the line, which tells us how much y changes for each unit change in x. And lastly, c is the y-intercept, the value of y when x is 0. What's important to remember here is that in linear regression, we're trying to find the values of m and c that give us the best possible fit for our data. By best fit, we mean the straight line that minimizes the distance between itself and each data point. This is done using a method called least squares, but that's a topic for another day. In essence, it's all about finding the best fitting straight line through the data points. Now you might ask, how does linear regression work? Well, let's dive in. The magic of linear regression lies in its simplicity. Imagine you're trying to draw a straight line through a scatterplot of data points. Your goal is to draw a line that best represents the relationship between the variables. But how do you define best? This is where the least squares method comes into play. In essence, it's a mathematical approach that aims to find the line that minimizes the sum of the squares of the differences between the observed and predicted values. Let's break this down. The observed values are the actual data points on your scatterplot. The predicted values, on the other hand, are the points on the line that correspond to the x value of each observed data point. The differences between these values are called residuals or errors. The least squares method squares each of these errors and then adds them all up. The line that gives us the smallest total sum is the one we call the best fit line. This line will give us the most accurate predictions for new data points. In other words, linear regression is a balancing act. It's about finding the line that gets as close as possible to as many data points as it can, without favoring any particular points. So, linear regression is all about minimizing the error and getting the most accurate prediction. To sum up, linear regression is a powerful tool in machine learning. It's a statistical method that allows us to understand and predict relationships between two variables. By using a simple equation, you remember the one with y equals ax plus b, we establish a line of best fit that represents these relationships. Let's not forget the stars of this equation: independent and dependent variables. Independent variables, or inputs, are the factors we control, while dependent variables, or outputs, are what we aim to predict. And of course, there's the least squares method. This clever mathematical approach minimizes the sum of the squared residuals, ensuring our line of best fit is, well, the best it can be. It's these residuals that tell us how far off our predictions are from reality. And with that, you've taken your first step into the fascinating world of linear regression in machine learning. Keep exploring,